see me. We don't have any free gifts, so you are free to leave now. We are going to speak only about some kind of communications and techniques that we use to make our communications more secure. We're going to speak about several clients. We will see a little bit vulnerabilities of Snapchat, and we are going to then speak about WhatsApp. So this is who we are. We are both from Spain. I know some of you. I'm speaking at Black Hat and DEFCON, and so I write a blog, you know, that kind of shit. And Pablo works for R&D for Optenet, this is a Spanish security firm. He has we worked together in this research of WhatsApp. We presented the first release on Black Hat. And I would like to apologize because we are a little bit tired because we have a very hard night. I know you're laughing because we are from Spain. Did you think that we like party like this way? But it wasn't. I promise it wasn't really because of this. It was something more like this. You know, the god of demons punished us. So I would like to thank, I don't know if he's here, Mike Bowen. Mike is not here, for giving us some kind of access point and some things we need to for the talk, like about 12 at night. So we're going to speak about instant messaging. You know that people used to send SMS, and now we are talking about that the quantity of the instant message are double the traditional message. It's like 23 billion of losses for the telecommunications company. And some facts about this kind of new technology to communicate each other are that most of these applications are used by teens, you know, because it lets you save some money. You use it in a smaller cycle because you have maybe 400 of friends on Facebook, but you only speak to about 5 or 10. That's what instant messaging comes to, because it lets you connect directly. And it's something that works on the present. It doesn't matter what you did in the past. This is not the case for Facebook or for Instagram when you put your photograph when you were at school. And some of these applications we have worked are like, you know, Quick is WhatsApp, it's Viber. We have analyzed several of them, and you know there are some flaws, there are some identity thefts. We are speaking about lack of encryption. There are several clients that doesn't use the encryption well. WhatsApp has a very important flaw. We will see it later. And there are some applications that doesn't use certificate pinning, for example, for the HTTPS connection. Some of them let you upload malware to the cloud, so you can just put your file into any client server and then throw it to your victim. And we'll see that we have one way of doing a denial of service. So first of all, we are going to speak about Snapchat. Snapchat is now more present because you know that there was a leak about the database. Snapchat works for iOS, works for Android. It's some kind of application to chat, maybe with another person. You really know it's only for 16, so send photographs or nude photographs of you to your girlfriend. And this feature that Snapchat has is like the pictures are self-destructing. So you can only see the picture for a short time, and then it should disappear. Some of the statistics for this are there are 100 million users registered. There are 400 million snaps a day. There's a huge traffic. There is a 25% in the UK using Snapchat. In Norway, there is half of the population that have mobile phone installed, and this problem is original from the United States. But you know, Snapchat only has one job. He only had to erase all that images you send to your partner. There has been some application like Snapchat. There's an application that lets you save the images you receive, and the other person, the sender, doesn't know it. The hackers at the Gibson Security Group published a full disclosure of the API. The Snapchat team thought that it wasn't very important, and several weeks ago, some person leaked like 4 million contacts of the database. And well, Snapchat, you know, they didn't apologize at first. Later they apologized. They say they're working, fixing this. So we wanted to see if we could do anything else. So this is the way you send the snaps. The way you send the snaps, you have to send your username. You use a timestamp, a request token, the data for the photograph. And we try to make some kind of magic, like, hey, let's change the account. Let's see what's happened. But you can change the account because it's related to a token. So let's erase the token. So we can send snaps to another person, but you have to have the profile public or use an account that is friend of everyone. The only account friend of everyone, you know, is Team Snapchat. So if you erase the token and you change the username, you can just be posting the snaps to every user. You can send every image you want. So this was a flaw that we discovered on Christmas. It's a fail for Snapchat. And it seems that Snapchat noticed that the request token and the username were important. On the 6th of January, they fixed it without notice everyone, so we like the full disclosure and we want to have a chat with them. It's like, hey man, there's 10 days until this Shmoocon as you are screwing up our presentation. So we sent them a message, but they didn't give us any response. So there is no way to spoof the usernames anymore. So we thought, what can we do again? The other idea was because people are saying that there's a lot of spam coming in the last weeks, and the company say that they want to apologize for unwanted snaps. They let you know the team is working, resolving this issue. Okay, so now we have to use the request token. The request token, it's made with the password. You get the original token, and then the timestamp. If you have the timestamp, it's because it has some specific time value to be valid. So we then try to make the spam. And if you see, these are the same captures. This is from 14th of January, and this is the same token used on 18th of January. The same token can be used for days. It's supposed to be only once. So what can we do? What we're going to do, we have intercepted with Verb. So what we are going to do is like see if we can send. So any malicious attacker could just send it to the attacker part of the Verb, and then get the receipt, erase it, and say like, I want to put my contact list I have from a 4 million leak database, and what could be happening right now? We have put first have our username, and we will be sending our toy from Shmoocon to all the database. You know, you have 4, 5, 10 days with a valid request token, but you can do like 4 million requests like in 40 minutes. So the spam problem is real. But another thing we wanted to know is, yes, well, I can send these snaps to everyone. Okay, we're going to do the same thing. We're going to change the media ID just to send it a lot of message to some user. I'm going to use some random values for media ID, and then try to make a denial service. So we start the attack. We have only one thread, but it works for us because we can send like 32 snaps per request to almost any user. So you can see we are spamming the user. This is my username. Don't worry, don't want to get in jail. So what we are going to do is send it as many messages as we can. We wanted to do some kind of denial of service and see if the application can support it. But there is one point that when you receive a lot of snaps, the problem is that you will likely get something like this. Last update, and then you're out. You're out, and you can connect to the Snapchat until the denial service is over. So there is no countermeasures, there is no protection for Snapchat. You can spam any user you have. In the last weeks, we can send snaps with the team Snapchat. So there is a lot of work to do. So I'm gonna let Pablo speak to you about the things of WhatsApp.
Hello. Well, WhatsApp is an application that came from USA. It is interesting to compare it with Twitter, that has 230 million of users per month, or Instagram, that has 150 million. WhatsApp says that it has 400 million monthly active users. It is the largest and most used application in instant messaging in Brazil, South Africa, Indonesia, and also in Spain, that reach 95% of users, all the people who use WhatsApp. And they usually they say they receive 10 billion messages per day. To reach an idea what kind of messages we are talking about, there are near 420 million of messages per hour, 7 million messages per minute, or 115,000 messages per second. Here you see the numbers of growing of users. They were 200 in April, 250 in June, and 300 in August. And you see two bars. The dark bar is lower than the green bar, because they say they receive more, something around 11 billion messages, but they receive 20 millions, because WhatsApp usually use groups that a message is sent to 3 or 4 of your friends, the same message. So we think that WhatsApp is doing to SM messages the same that Skype said with international calls. This application has a long history of security faults. It starts sending the messages in clear and plain text. So if you are in the same Wi-Fi, you could see all the messages that were for example, in Starbucks, if you use it. Then, I think in 2012, they start encrypting the messages, and they commit a fault that was the user ID of your account in WhatsApp is your mobile number, and the password of that account is the email of the mobile or the MAC address in iOS devices. So in November in Barcelona, we show a tool that let you read the messages that a client receives if you know the MAC address, for example, of an iPhone. They also let you to store remote virus, program, HTML, JavaScript, almost all type of files. The only one they don't allow you were PHP. And you can do this without telling the username. There was a public storage for you. They also store the database of messages inside the phone in plain text. It's not encrypted. And another issue was that a unknown hacker published a website where you can change the status of the users. There was a phantom application that was removed without any explanation. Piñata worm that was spread through your contact list. WhatsApp Voyeur is a Spanish website where you introduce the mobile phone of a person, and you can see the status, the photograph of his or her profile, and also the sentence you use in your contact list for your contact. Um, and WhatsApp doesn't have any kind of protections or only receive the messages of your friends. So anybody can send a message to everybody. So spam is also a threat in WhatsApp that is not fixed. And they also have a bad encryption process of the messages. So this is why we are here. These are some threats that are presented for WhatsApp. Steely Genie that allow a person to spy and dump instant messages from the mobile phone. An email fake WhatsApp notification was also I received in Google, in Gmail. An Android game that steal your conversations. And WhatsApp Spy, that was a fake spy application. I don't know why everybody wants to spy you. So we got an idea what we can do with this. So we think about to add 3 layers of security on WhatsApp's messages. The first one was to encrypt the messages, so when they are stored on WhatsApp servers or they are not visible, they are not in clear. And when the second layer tries to not to communicate directly, because sometimes from metadata you extract with the people you talk. So if you change the number with you are talking to reach the final destination, it's not a one-to-one conversation. And the last one, we think to change and to store, to send the messages not through the WhatsApp servers, although through our own XMPP server that you are owning. All of these things is why I let Jaime continue.
Well, thank you. I've seen Mike. Thank you, Mike. I know you were trying to hide. You have free beer all day. He's paying. So let's speak about surveillance. You know that there were some kind of reports leaked by Snowden that shows that there was some kind of mechanism called PRISM that trying to monitor all the information about the people, all the communications, all the texting, the social networks. So if they are able to get all the emails and all the information metadata about us, we ask if not only Microsoft, Google, Apple, all these companies could be inside this PRISM. Maybe it could be that WhatsApp, with so much information going through its network, could be inside too. Well, it seems like just today they showed up that people from NSA were spying to the SMS. So they take like 200 million text messages a day through all the earth, including location, contact networks, credit card details. So on average, you can see that there is 5 million missed calls. There is the details of 1.6 million border crossing day, all the roaming alerts, and over 800,000 financial transactions. Excuse me. So, could be instant messaging the next target, if it's not now. We are going to explain some of the things we have done within WhatsApp, including adding a new layer of encryption, adding some anonymity, and having your own XMPP server. So let me first explain how does WhatsApp works inside. You know, this is the capture of a packet from WhatsApp. It's trying to start the negotiations for the login. In this case, you're going to see that you have the X bytes, and you have then the meaning of each one. That's because WhatsApp uses some kind of a special version of XMPP. It's called FAN XMPP, and what they do is all the constants, they reduce them to only 1 byte. That's because WhatsApp is used on mobile phones and you have to reduce all the size of the packets you are sending. And this is a decrypted packet we have found by sniffing all the communication from our phone. So the first thing that WhatsApp tries to do is log in with a new device. So when you buy WhatsApp or you download from their store, you have to send your phone number to the server, and then it answers you with an SMS with a code. You put this code on your telephone, and then it begins negotiating, and it gives you one password. In this case, they use SASL mechanism. It's called WhatsApp Authorization 1. It's like what we are seeing. I don't know if you can see it. But the first thing you do is try to log with your mobile number. And the server, instead asking you for the password, he asks you for a challenge. In this case, he's sending you a challenge, and what you're going to do is use pkb df2 with the password, and this then using sha1 as the hash function. And then you pick up the first 20 bytes, and then you answer to the server. That's when you know you are connected. There is no transmission of the password. That's a good thing, because until now WhatsApp was doing is sending the password directly. So we began thinking if our messages were secure. These are words of WhatsApp. It's like WhatsApp communication between your phone and our servers is fully encrypted. Yeah, fully encrypted, yes. But not the way you would like. So they are using RC4. You know, is this widely used. It was designed by Ron Rivest. You maybe know RC4, but some flows that were exploited in Microsoft some years ago. And it has 2 stages, but it don't really matter here. So if they're using the encryption and you can use RC4 in a good way, where is the problem? So let's speak about Alice and Bob. So suppose Alice wants to send a message to Bob through a public channel, and they have a share key. So since Alice is very, very lazy, she doesn't know a shit about string ciphers, she decides to reuse the same key. So there will be one person that gets all the message and do the XOR function, and she will have the XOR function of the ciphertext. You know that every time Alice encrypts a message, God kills a kitten. Yeah, you know, it's always Alice, always Alice. So what you can do, we saw a proof of concept in the last conference, is attacking it. It's like you are using the same XOR password. So what we are going to do is like do some kind of plain text attack called crypt dragging. And what we are going to do is guess a word that may appear in the message. And you know there is a top list of every language with the most used words. And then we are going to encode it and try in every position until it gives us a clear text. So when we have one character, what we are going to do is then beginning like testing all the positions until we can find the original message. We're doing this the manual way. We suppose that we can use an automatical way to do this, because we know if you get all the connections from the beginning, you know that the first message has some bytes in several positions. So you have only to try what character will be in that position to know the original byte. But there were other attacks we have found. The first one was attacking the client. So what we're going to do is using Josup, it's an API implementation of the WhatsApp protocol. And we're going to send a message to our mobile phone, you see. And what we're going to do is trying to crash the application. We are trying to encode some special characters and send directly to the phone. And you will see that when you send it, WhatsApp's over. So every time you want to enter the WhatsApp, it will crash. So if you have sent maybe someone some kind of works that you deserve, maybe you can send this kind of message and he will be unable to recover the conversation anymore. But there were another thing we thought that, well, we have the communication, it's use the HMAC for having the consistent message, but maybe we can spoof the message. You know, it's like WhatsApp doesn't store the message on its servers, so if we can fake all the message, and you can do it at forensic to my phone and you find there is nothing wrong, maybe I can demand you, for example, and you have a legal problem because I'm putting in your mouth words you didn't say. So maybe I'm going to tell that you have threatened me, and the only thing you have to do is like the message has a special field. This is like a checksum, but it doesn't test if the original checksum has changed. So we have the first message from my mate that's called the Shmoocon contact. And what we're going to do is throw the application through a VPN, and we'll begin controlling all the messages that we are receiving. So we're going to first try to do the first thing. For sure, it's a fake number, because if you can see, there won't be any phone number that it's all zeros. And you can see that is true, because not that part. If you can see, there's only edit message. This is not a contact that I have had to my phone, because the original one, you see, was the Shmoocon, and you can call, you can edit the contact, you can get the information, but this one doesn't have it. So I can put whatever telephone number I want. But we then go and say like, hey, I can communicate with him and send it like a fake conversation, but only, does this only really works from numbers? May I put some special characters in the phone number, and then we try again. We send a message, excuse me, and then, hey, the contact is M2 Elite. Yeah, it's a fake number, but you can see the power of this is if we are able to capture the token, we can do a man in the middle. Maybe what we can do is send the client a message from the server telling, hey man, there is a new upgrade which lets you call wherever you want and see free nude pictures of all the girls you want. And then download this APK. The user install it, and it's owned. So what we have developed is a new temporal solution, because it will work until WhatsApp change the game, upgrades the protocol, and then we go behind them. And it's adding all these kind of layers of encryption that Paulo will show you now.
Well, the first security we set is an additional encryption layer. What we do is, as we can control the conversation and we are in, what we are going to do is that Bob and Alice, Bob is red one, Alice the blue one, before the message reaches the WhatsApp servers is going to be open. We remove the R4 encryption layer. We get the text and we apply then an encryption to the text, and then we reconstruct the message with RC4 and send to the WhatsApp servers. And when Alice gets the message, before it reaches her phone, we again open the message and remove the encryption layer so she can read the message. We get some troubles because on iOS versions, the challenge the server sent in some versions weren't clear, but when in some versions in the future, they changed the challenge, and the challenge was in the first communication in the login. So what we do is to flip some bytes of that challenge, and WhatsApp server responds us with a clear challenge so we can enter the conversation. And for the second mobile, we do it again. When sending a message, what you can see here is the client pilot, and there are some fields that are enhanced. The second message, the TY message, is the cipher message we receive, and TY message is the decrypted message, and it's 4 bytes length, less of length, because we remove each MAC because we have to regenerate them. And the 200 we have there in green is saying that the message is sent to the red color, the red box is the phone number. Here's 34609 and so on. And on green we have the AXT text. Here is Velo. We apply a key and the message is gone in red and is not legible, it's not readable, and we send it to WhatsApp servers. So when then you receive this message on the other phone, you open it, you have a 65 that says that the message is from the server, and you have the phone that sends that message. This is the red box, and you've got the text in encrypted, and we don't read it, and you send the key, you got it again in Velo in clear text. So that's the encryption layer. The program starts, and we are going through the VPN. He's going to connect. These are the troubles because we have slow network connections and some other troubles. And here are the message we send. Here you can see the login and the challenge, and the message I sent to Jaime. He responds me, and you can see hello world down. And again, I send Jaime another text that you can see it's fine, and the cipher text there. And here is the hello message, and the first message I sent to Jaime that is 23 bytes length. And here is the cipher text and how the program decrypted and set it again in text plain. Without the key, this works because Jaime and me, we have a private key that we share. And without that key, what you will get is something like this or something like this. Well, anonymity. To what I was telling, to remove the identity or the direct connections with your friends. So what we do is we generate some YouTube clients. It's a free API for making YouTube to interchange WhatsApp messages from your computer. And we create some bots with some virtual numbers that are not usually on phones. And when Bob contacts Alice, instead of reaching dial, the phone number is going to be changed to the first bot. Each bot has something like a route table that when you receive a message from someone, you know where to send it to the next hop. And the final layer we add is to use our XMPP server. So WhatsApp is not going to have the message in cipher or not ciphered. He's not going to have the message. How we do this? Well, we get again the message. We are in the conversation of WhatsApp, and what we do is to get the text and the destination number and message ID that has all the WhatsApp messages, and we pull it together and send to our XMPP server. So the other contact will enter our XMPP server and get that message, and when the message arrives, it's going to be able to reconstruct. The text is going to be replaced by our wildcard character. In this case, are Gs, because we like Gs. It could be any other character. And WhatsApp is going to see this on his servers. When this message reaches the other person, it's going to be reconstructed. And we say this. Thank you.